hope that hello guys, I hope that all are doing good. So today we'll be starting a C playlist, and I'll be covering the C programming from the very basics. So it is basically being targeted for the non-CSC students. So if you're an advanced CSC student, you can watch it still, but we are covering the very basics of C programming, like how the C program runs, what the memory is. So we'll be starting with the very first unit, in which we'll be covering like what is the memory, what is program, how to run it, and what are different types of memories, where the program resides, and where is it executed. So basically what happens, we'll try to understand it with the help of an example that you use on the daily basis, okay? So that example is your mobile phone. So for example, you're having your mobile phone, and let's try to just create it. Okay, so you're having a mobile phone. So whenever you go for buying a mobile phone, you always see that how much memory does it have, how much RAM does it have. So there are only two types of memories, primary memory and the secondary memory. So the secondary memory is something that is not required for your phone to run, but the primary memory is. Okay, so for example, if you're buying a phone which is 256 GB or 512 GB or 1 TB, so that is the secondary memory. Okay, so and the RAM, which is like 8 GB, 4 GB, you see, you hear all these terms, right? So secondary memory is something which is not required your phone to run. Like if you are not like this is the case, like if you're not having your photos on your phone, that doesn't mean that your mobile phone will not run, right? But if your primary memory is quite low and you're having multiple apps, then sometimes your phone hangs. So what is the reason, and how all these programs work in your device is actually a thing that will help you to understand how C program gets executed. Okay, so let's consider. So I'll be writing here like these are the photos that reside in your secondary memory. Okay, this is your secondary memory. I'm not having very good setup for creating this video. I'm just using Paint and something that is available to me. I'm not having mic as well. So the main concern is to make you understand, because your exams are reaching out. Okay, so this is your secondary memory, which can be extended, of course. Okay, and this is your primary memory. So what happens is, when you're suppose any application, so what is program? All the applications that you run on your phone, be it Instagram, be it LinkedIn, like all the softwares or the applications that you run, that are collections of programs. Okay, so how you run it? Suppose take an example of Instagram. So Instagram is like you go to your Play Store, you search for it, and then you install it. So what happens if you want to install it on your PC? So you search for exe file, or whenever you download the setup, they will give you the executable file. Okay, so the program, the collection of program, for example, this is your Insta C file, your Insta C file, which is having multiple programs, 1 2 3, multiple programs. So all these programs are then converted to your executable file. So how is it done? Through the compiler, the different modules that are listed in your first unit. One of them is compilers. So all the list of these programs will be converted to your exe, and who will convert it? Your compiler. Like whenever you write your C program, you compile it. The compiler converts your C program to executable file, and then this file is executed on your device, on your mobile phone or whatever, your PC system, whatever it is. So this is the work of your compiler. So we write our C program, something.c file, and then it goes to your compiler, GCC or whatever compiler you want to use, and then it gets executed on your device. So this is how your mobile phone works. All the apps are just collection of your programs, and then they are converted to exe files so that they can be run, they can be installed on your PC or on your system, on your computer, and then you run it. Okay, so all the different applications, when they get installed on your PC, on your laptop, they does reside on primary memory, but to run them they need to be somewhere in the core. So the primary memory is divided into two parts basically: RAM, okay, oh my god, how am I writing, but I can't help it, and ROM. So the name, you know, ROM is read-only memory and RAM is random access memory. Read-only memory is something that is required for your phone to run. It has nothing to do with you. Whenever you start your phone, your laptop, your PC, all the input, output, or whatever is attached to your PC is booted through ROM, like BIOS for the very first example, the booting process. ROM is responsible for that. Okay, and what the RAM does is, like, all your programs, all your apps, they run on RAM. So what is the size of your RAM? Like 4 GB, 8 GB, that matters a lot. So that is why we always focus on, you know, the RAM memory capacity. So whenever your PC is started, ROM is responsible for booting what is attached to your PC. Okay, and then your operating system is initiated. Operating system is nothing but an interface that resides on your device, which makes you interact with your device, like which makes other applications, like who will interact to your PC? Different apps, right? We will be installing different applications to use this phone. So all these phones will be interacting with your PC with the help of operating system. There are multiple types of operating systems. Being it mobile, so you'll be having iOS, Android that we use, and on your PC you're having Windows, Linux, Unix, multiple types of operating systems. Okay, so in your mobile also, whenever you open any application, no, that application gets into your RAM. So if the RAM is free, it will run smoothly. But if you are having multiple applications like Instagram, Facebook, LinkedIn, take it like multiple which exceeds your RAM limit, then your phone starts hanging. Okay, so that is the work of RAM in every device. Similarly, in C programming as well, whenever your C program is compiled through your compiler, it gets the executable file, and then this file is loaded to your RAM for running, for execution. And who does that? Is your loader. So we'll be covering what different types of devices these are. So this is the whole scenario. So your mobile is having two types of memories: primary memory and secondary memory. So secondary memory is something that is secondary. Your phone does not need this memory to run. Okay, so if your phone is not having photos, that doesn't mean that it will not work. Okay, the main thing that is required for your phone to run is your primary memory. You know, that is why it is named as primary memory. So it is divided further into two parts: RAM and ROM. So ROM has nothing to do with you. It has like your PC when booted, it has something which is read only to you, but your phone, your mobile, your device needs some things to start with. Like whenever you turn on, what will happen? That is written in your ROM. Okay, after ROM, your operating system is starts, and then all the applications that you can access are available. So the RAM is whenever you click on any applications, that gets loaded into your RAM. Okay, then that will get executed. And similarly, this happens with your C program as well. It will get converted to your executable file through the compiler, and then it will get executed on your device. Okay, so now let's see. So this is the diagram and only. So CPU, which will be processing, which will be executing your program. This is your storage, that is secondary memory, and this is your RAM that is required for the program to run. And all of these components are managed by your operating systems. Okay, so these are the input output devices that are connected to your system, whatever it is. So the next is, so I think I have covered the memory, which is used for storing data and the processes as well. So primary memory, secondary memory, cache is something like you can say that is a part of your CPU, or that is residing your in between the CPU and the RAM. For example, it is a little window. Okay, so something that you have just executed, so we took that application to our system, and then we are just browsing it. Okay, and so then we switched to the another applications. Then again, when we open the second last application, we need not to load it from there to RAM. So there is a window which stores the recent opened applications. So before loading it from your primary memory to RAM, it checks that whether it resides in cache or not. So if it does, it does not need to be loaded again, right? So it is a small amount of RAM, you can say, that is more fast than the original RAM. It is not a part of RAM, of course, but it resides more close to your CPU as compared to your RAM. So we have covered the RAM and ROM thing, and the processors. So it is having ALU and CU. Register is nothing, they are just a storage memory storage unit, 1 bit. They are used to store data. Okay, so the main things are CPU and ALU. Okay, so to do A plus B, the addition will be done through ALU. But to instruct the ALU that you have to do the addition on A and B, it is the task of CU. So CU controls the operations. Then it will be loading the value of A and B, and then ALU will be doing the addition part only. So it performs the operations, and it directs the processor, the ALU, to perform which operation, to perform that operations. Okay, and then next is we have covered, what are input devices and what are output currently. So the storage devices, they are basically considering the secondary devices, how you can attach the storage, like using HDD, that is your hard disk, or using your USB that can be removed. Okay, so the operating system, it is a software that manages hardware and software resources. So whatever is connected, it is being managed by your operating system. Everything is done by your operating system. Okay, so next are different types of examples are Windows, Unix, Mac OS, Android. These are all operating systems. Okay, so these are their functions we have just discussed. And the next part is this. It is quite important. Okay, so what does assembler, so compiler we are clear with. So compiler will compile the high level. High level is nothing like the programs which are you able to understand. So there is a machine language and human language. Okay, 0-1 form is machine language. This is binary form. So you are not able to understand binary form. So we have created some languages, some programs that are that we can read. Okay, these are called high level programs. So to convert, like for example C, Java, all of these which you can understand are high level languages. So to convert these high level to machine language, to make it run to your system, to convert it into 0-1 form, we need to compile them to convert that to machine language. Okay, so the compiler does translate the entire high level program into machine code before its execution. Okay, interpreter is similar as like compiler, but what it does is, like, instead of translating whole program at a time, it will translate one line at a time. Like, before the semicolon, it will translate that to your executable code. If the error occurs, it will stop, but the compiler will compile the whole program and then collect all the errors. interpreter will stop whenever the first error occurs. So it will interpret, it will convert the program line by line, and it will convert entire program at a time. So loader, we just discussed that it will load your executable file to your memory for the execution. Okay, so now let's discuss linker first. So linker, what it does, I'll be explaining it with the example of a program. Okay, so what does assembler do? As like C or Java, the initial, there are other languages as well, like which are microprocessor dependent. Okay, which are called assembly languages. So these are not purely 0-1 form languages. They introduced some instruction set like add, sum, and del. So these are the instructions that were introduced initially, which we can write for our programs. Okay, so these are called assembly languages, which are not binary languages, which are not high level, but they reside in between. Okay, so assembly language is converted to machine language through the help of assembler. So these are microprocessor dependent languages. You can just go and look for a program that is in assembly language. It does look like your high level language, but more microprocessor friendly. Okay, so compiler converts our high level languages to the machine code. The assembler converts the assembly language to the machine code. Okay, so we have just discussed this. If you are having any doubt, you can comment it down and I'll be replying as soon as possible before your exam, of course. Okay, this is the whole pipeline of how the execution is on your source code. It gets processor and then the compiler. So all of these resides like in one block. The compiler will be converting it to the machine code, and then the part of linker and loader. Okay. Okay, so is there anything? Let me explain linker only. So whenever you are doing this, like for example this one program, so I am using one global variable. So in this program, this is defined, but if I do not define it, I just declare it now, then the linker will try to find this particular variable which is defined in another file. So we have to mention that. So if we want to use something that is defined in another file into our program, then that is it might be a function, it might be a variable. So that is done through your linker. So if you are residing in this file and you are using something that is defined to another file, then that file will be mentioned here, and the linker will go to that file and find this variable and assign that particular value that is assigned to this variable into this particular file. Okay, so linker is just connecting the chunks of program that are residing on different files. So we'll be understanding what this file is. Firstly, let's go. You will get to know when we'll be addressing the main idea of program, how it works. Okay, so next is algorithm and flowchart. So flowchart is how your program is being executed line by line. It is the flow of your program. Like it starts, then it gets the input, then it checks what is greater or less than. It will be done in the time. It will be come in rhombus, I think. Let's change it. So I'll change it. I'll update it and share it with you. Okay, so the different shapes of what is being used in flowchart are defined with their functions. So every program starts with an oval and it ends with an oval as well. A rectangle takes the input and gives the output, and it also processes whatever, like a plus b, a minus b. The processing is done in rectangle. If you want to make a decision, then you use a rhombus or a diamond. Okay, So then comes the, so algorithm is the actually your C program is the algorithm only. Firstly you make an algorithm, like what is going to be the main flow of your program. You define the steps. I'll be taking the input, and then I'll be checking, I will be comparing their values, and if this happens I'll be doing this, and if this happens then I'll be doing that. So that is your algorithm only. So pseudocode, algorithm, and C program, these three are basically different representation of what you are doing, different representations of your C program. So the pseudocode is, it is human readable form of your program. Like I began the program, I took the input, if A is greater than B then output is A is largest, as if B is greater than A then output is B is largest. Or otherwise both are equal, and then it ends. So this is the pseudocode. And if we want to write this program, I think you must be knowing it. So we'll be coming to this now, what are different parts of this program. Firstly, just know what is this. This is to another topic, that is data types in C. So basically this this particular topic is basically categorized into two types, user defined data types and built-in data types. Something that are built-in like integer, float, double, char, all of these are built-in data types, and you can make another data types by using these primary data types. Okay, so I'll be sharing that chart with you as well, but you need not to go into that much deep. Just know that these are basic data types that will be used in your programs. So the integer, float, double, char, void means no value. So these are derived or user defined data types, or secondary you can say. And how to, the difference, like you can just give the data type and then how to access that. Like percentage %t is used for accessing the integer, percentage %f is for float, this for float, this for double, this for character. So this is a program that is just showcasing the use of data types in C. Okay, so now the next topics, what are variables, constants, and what are the storage classes. So variables is something whose value keeps varying in the program. So whenever you take a simple, say int x equal to 10, then you can say then you can do x equal to 11, then 12, you can change it. That is your variable. Okay, named memory locations whose value can be changed. Constant, if you just write this keyword in front of your variable, then it will become a constant whose value cannot be changed throughout the program. Okay, and then the storage classes, how to store your values, how the values get stored when your program is executed or whenever it is compiled. So now regarding the storage classes, the very first one is auto. So automatically the every function is having its own stack. So if there are having 3 functions and 3 index in every function, so each index will be having different memory blocks. So in 3 functions we are having 3 index variables, so 3 memory blocks will be assigned to that integer variable. So on the other hand, there is static. So static, if you want only one memory block to be shared for all 3 functions, so then it will be declared as static. And the external one is something that is something is defined in another file and you want to use it here. So you will define the file over here, like for example it is defined in another file, for example #include a.h. So make it extern, so it will be finding the loader. What will the loader doing here? So it will be going to AA.h file and it will find global count variable over there. If it is present, then that value will be assigned here. So for that we'll use extern, like something that is externally available. And the last one is register, that is very close to CPU. It is like 1-bit storage unit. You don't usually use it, so it is for CPU and fast storage purpose. So the last is Standard input output in C. So basically, what are the different types of input and output functions that you use in C? So printf, you know, for giving the output to the console. Scanf is something to take input from the console. You use it for percentage %d and then a variable name. Putchar and getchar are something that are single character input output your functions. Like if you want to take just one character, then we will be using putchar and getchar for the input. So puts and gets, they are used for string. String is what? Collection of multiple characters. So these are the specifiers which are used for different functions. I think you must have used it. So with this our first unit is ended here. So let's just get into the first program, that what are different parts of a program. Okay, so this is our first program. Like this is the preprocessor. The hash keyword is used for preprocessor. It will be including this particular file. The hash include will be including that in this particular header file. So header file is nothing but, you can just imagine it as a book which is having multiple functions defined in this. And if you want to use these functions like scanf, printf, then just import this particular book to tell the compiler that I'll be using these functions. Please import, please include it. And then this the main functions. Of course, now you know that the execution starts from the main function. Okay, so main function starts here and it ends here. These are simple variables, int a and b. Then you are taking the input from there, and these are some conditions, and with the conditions you are printing the output. And this return, this is the return. If you don't want to return anything, just make it like void and it will not return anything. So for running this particular program, you just need to install any editor, or you can use the compilers as well. So let's execute our first program. So this is the first program. Okay, so you will just write it. If you're using VS Code, you just do not need to do anything. Just to go to the extension and include the C and C++ compile run. Then download your compiler, the GCC one, install it, and then you have to just write your program here. Okay, and then for compiling, so what we have just discussed is that our program will go to the compiler. So how will it go to the compiler? Like, this is the compiler name, and then your program name, hello.c, and then in which file it will get converted to the executable file. So we'll write output hello.exe. So now the compiler has executed, the compiler has compiled the file, and it is saved in hello.exe. And now we will just run it. How to run it? Dot, then slash hello.exe. And what we are doing in the program? Just printing hello. Now just compile it. Sorry, we have compiled it. Just run it. So we have just got our output. So we are having header file, our main function, and it is the function that we are using. So printf is a function which is defined in stdio.h, standard input output header file. What other function it has? It has scanf, and we will be discussing more functions with more header files in upcoming videos. So if you find it useful, please let me know in comments so that I can make another video on your next topic, and I'll try to make it as short and as informative as possible, so that not much of your time get wasted. So thank you so much for being till now, and let me know if you want another video. Thank you.